afternoon, my name is Nikolai Kolabutin, and today I present you our paper Dynamics of Wave Processes in the Drifting Ice of the Arctic Ocean in the MOSAiC expedition. First, I give some introduction. One of the main directions of the theoretical and applied research in the Arctic is the study of physical and mechanical processes in the system atmosphere-ice-ocean. For this purpose, the theoretical and experimental problems are solved. The paper employs the method of monitoring the state of drifting ice by means of autonomous seismic stations in the MOSAiC International Expedition in 2019-2020. The method of remote registration of ice information with the readiness of 100 kS made it possible to obtain data on the processes of compression and crushing of ice of various temporal and spatial scales. The paper presents early findings on the development of physico-mechanical processes in the ice cover under influence of wind, ocean gravitational waves, compression and crushing phenomena during the large-scale deformation in drifting ice. The amplitude-frequency spectra of surface gravitational waves obtained in this work provides sufficient reason for attributing the phenomena described to swell waves and infragravity waves that occur in the stormy arrays of the oceans. New data have been obtained on low-frequency horizontally polarized waves caused by compression of ice and movements along bricks in cohesive ice cover. The article considers possibilities of using instrumental monitoring of the occurrence and development of tidal compression and crushing in the drifting ice of the Arctic Ocean. The obtained results can be used to develop methods for predicting the state of ice in real time, both in engineering tasks and for improving weather and climate forecasting models. On a MOSAiC expedition, we used 3 autonomous seismic stations on the ice. Each seismic station consists seismometer for registration of ice cover oscillations in 3 orthogonal directions, and inclinometer for registration ice cover slopes in 2 orthogonal directions. Seismometer we used SME 4311, and as inclinometer we use IND3. You can see photo of these sensors on the slide. These 3 seismic stations were stayed on the ice apart from each other. Each station had their GPS antenna for synchronizing time and space coordinates and radio antenna to transmit the signals from the station to the base stations placed on the polar stand. And with the base station we can monitor the signals from the stations in the real-time mode. On the top right photo you can see the monitor connecting to the base station, which shows us the line of the ice cover oscillations. During the entire period of observations in the MOSAiC expedition by using seismometric methods, there were recorded several ice events which reflected the intense dynamics of drifting ice. The mechanics of the ice destruction, both at the level of local through cracks and extended shear ridging and formation of leads, was solved using appropriate methods for determining the characteristics of elastic and gravitational waves. At this stage, we present a picture of ice dynamics with the manifestation of processes in the system ice, air, ice, water. For example, consider data from seismic station on the ice sheet on March 2020 for comparison with deformation kinematics of ice field. Here you see oscillation and waves in the ice on March 1 to 26 with some metadata, speed of wind, temperature and air pressure. As you see, intense strain of vertical oscillations on March 1 to 5 with the week's wind speed, and intensive ice destruction occurred on March 10 to 13 with against the background of vertical fluctuation with a period of about 30 seconds. Here are some supplement to the previous slide. On the top left you see increase in the frequency during 36 hours. This is the movement of the cyclone to the station. On the top right you see almost constant frequency of background oscillations and movement of the cyclone and the beginning of the wind intensifications, some constant frequency. And horizontal oscillations are the result of large-scale mechanics of deformation and destruction of the ice sheet. This is on the low. Here oscillation and waves in the ice are March 10 to 12 with the ice slopes also. On the top of picture there are surface gravitational waves and shear movements of ice. On the lower picture the sharp tilts of the ice are, this is the result of process on the longitudinal banded buckling. Here is some addition to the event on March 11. On the top right picture you see the main impulse on March 11, and on the low again surface gravity waves and shear movements of ice together with tilts of ice, buckling again. Here is another addition to the event of March 11, vertical and horizontal Zug, which have elastic signals when deformation stresses are relieved during buckling, and the sharp tilts of the ice are the result of the elastic plastic processes. Here you see oscillations and waves in ice on March 14. After a storm, oscillations in the ice occur with a period of up to 30 minutes. And you see on the picture swell infragravity waves, horizontal shear oscillations, and these oscillations occur after the storm 9 hours later. That's it. On the question of infragravity, a series of spectra shows an almost constant frequency of the background ice oscillation at the frequency 0.03 Hz, together with a swell from a storm 0.04 Hz, and then the beginning of amplification of ice oscillations for the wind at frequency 0.08 Hz. It's interesting. Here oscillations and waves in ice on March from 18 to 21. During March 18 to 21, background oscillations were constant with the period of about 30 seconds. And here you see horizontal oscillations, vertical infra-oscillations period of 30 seconds, and wind oscillations of ice a period of 10 seconds, with the wind speed from 2 to 25 meters per second. Here is supplement to the event on March 18 to 21. You see spectrum of elastic waves on March 20. With the vertical oscillations, flexural gravity waves, and waves during destruction of the ice. Here oscillations and waves in ice on the March 26 to 31. You see displacement velocity and oscillatory acceleration in the ice before and after wind explosion. Interesting, an event with the occurrence of periodic processes in the ice. The duration of the event is 12 hours and the mechanism is not entirely clear. Very interesting. This is addition to the previous slide, one of the moments of periodic oscillations in ice on March 29. Event with the occurrence of periodic process in the ice. The mechanism is not entirely clear, but it's obvious that there is a horizontal self-oscillating process with the intensive destruction of cohesive ice by compression and shear. So, as a conclusion, during the MOSAiC expedition, unique events of ice destruction by gravitational waves were recorded in different periods when vertical oscillations with elements of fracture mechanics were noted in the light wind conditions. Separate events are vivid example of the phenomenon of dispersion of surface waves in the ocean when at large distances from the source there is increase of the length and speed of the wave. Wave spectra with the periods of vertical oscillations from 10 to 12 seconds characterize the well-known phenomenon of resonance between velocities of flexural gravity waves and wind, at which max flexural stress and accordingly mechanical destruction of ice should be expected. Thus, it's possible to control the time of occurrence of extreme ice events when deformations during the bending of ice field can reach wicked stresses. We want to say special thanks to Jennifer Hutchings and Gary Hapola, organizers of our MOSAiC dynamic team meeting. On this meeting we have very interesting and useful discussions and data changing. It helps us very much. That's it. Thanks for your attention, and please, any questions or comments?
I think you can hear us.